In this video, I am going to walk you through a typical free radical substitution question that you find in A-level chemistry, AP chemistry, as well as international baccalaureate. And I would say slightly harder than the usual like methane or ethane plus chlorine or bromine example you see in textbooks, and some easier exam questions. I'm going to walk you through the three main steps of the free radical substitution mechanism, which are initiation, propagation, and termination, and apply those steps to this question. So it says A, for the conversion of 2-iodopropane to 2,2-diiodopropane, write a balanced symbol equation. Give a pair propagation steps to form 1,2-diiodopropane from 2-iodopropane, and then finally some termination steps. So we've got propane 1, 2, 3, and the second carbon is an iodine. So just doing displayed formula here, and it's been turned into 1,2-diiodopropane. So a second iodine is going on to the first carbon. So let's start with the equation. So the halogen, obviously in this case, is going to be iodine. To balance this, if you just check, we have 3 iodines on the left, we have 3 on the right, 7 hydrogens on the left, 7 on the right, and 3 carbons. So it's actually it's balanced. Before we look at the actual mechanism itself, let's consider the different steps of the mechanism. In the first stage is where we have initiation. So I'm just going to write some notes here. So please do take notes on this bit. And in the initiation, the halogen is split in UV light. So chlorine and bromine undergo photolysis, which is when sunlight splits the halogen into free radicals. So individual chlorine atoms or individual bromine atoms, whatever the halogen is. Fluorine, by the way, doesn't undergo photolysis because the bond is too strong. So it's predominantly chlorine, bromine, and iodine. So that's the initiation. Then in number 2, we have the propagation. Now this is a repeating. To propagate means to continue on and on. So it's a repeating mechanism. And I'm just going to write the word equation because it helps to sort of understand the sort of cyclical nature of this mechanism. And once you've understood the sort of word equation for it, it's very easy to predict what the next steps are going to be. This is how it works. In the first bit of the propagation, we have the free radical. That reacts with the organic molecule, which is in this case C3H7I. Then what that does, it produces a new free radical plus your hydrogen halide. Always produce hydrogen chloride, hydrogen bromide, hydrogen iodide in the first step. So X, if I just write here, X is the halogen. So that's the sort of first bit, part 1. Then in part 2 of the propagation step, the new free radical reacts with the halogen, so the halogen diatomic, that is. So not the free radical, but the diatomic molecule, so basically X2. So the original molecule before it splits. So actually I should go back and add, that should be halogen, just to remind us that the halogens are diatomic. And then that forms your new organic molecule plus the free radical, the halogen free radical. What we see is in the first step, I just circle the free radical is used up, if you like, in the first step, and then it's given back to us in the second step. So actually the radical can be thought of as a catalyst. So this acts as a catalyst. So catalyst is a species that participates in a reaction but is not used up. So you can see that it's regenerated, and that can go back to the start and cause the split of the same organic molecule. Or, well, actually, in addition to this new organic molecule that I've just outlined in black, that becomes the starting point now. And then the new reacts with the free radical, as in, the original halogen free radical, because it's just been remade. And guess what? It goes again. And the process repeats. So basically, for every stage of propagation, so each stage of propagation involves 2 steps, as I've just shown there. So for each stage of propagation, it involves 2 steps. And in the second step, you must get back the free radical that was used in the first step. So I promise you, if you use this framework for every single one of these questions and you memorize like the word equation, all you have to do is plug in the free radical that you have, plug in the organic molecule that you're given. It could be propane, it could be butane, it could be like the one we have here, and you will get you'll get the correct answer. So termination, this is demonstrated best using this actual example, but termination, right? In the termination step, what happens? It involves combination of free radicals. So only the free radicals. So it involves combination of free radicals from the very first step of propagation. And that's really important. A free radical substitution mechanism is also described as a chain reaction, like nuclear fission in physics, where you split an unstable isotope, and that's a chain reaction. Once a chain reaction starts, it just keeps going and going until something stops it. Okay, so this this is an example of a chain reaction. So logic tells us if you want to stop this reaction just continuing until all of these hydrogens are completely swapped out for iodine atoms, so you end up with, which you potentially would end up with C3I8. If you want to stop it getting to that point, then logically you want to stop the reaction in the very first step of propagation. If I just put a star there, what is the very first step? It is this one, of the beginning of the mechanism, literally the very first step of propagation. You need to stop it at that point. So a combination of the free radicals from the very first step. So what are those radicals? If I just put a little dot there, it's this one. It's the blue, that one combining with that one. Okay, so I'm talking about those two. And I'll demonstrate this with this actual example. So that's how you would terminate this reaction by combination of those radicals. So let's take a look at the actual question now. So give a pair of propagation steps for 1, 2 diodopropane and some possible termination steps. So let's get into it. Step 1. So we got initiation. And in the initiation, we're going to have, so I2 is going to split under UV light. And then it's going to produce I dot plus I dot. So 2 iodine radicals. So that's the first stage. Then for propagation, think about what I just said. So I'm just going to do one cycle to show you. So I dot is going to react with the molecule, the organic molecule, which is C3H7I. That is going to produce C3H6I dot. So that is the new radical. So if I just scroll up, that's this thing here. I just tapped. Plus a molecule of HI. Then in the second step, the C3H6I dot reacts with a fresh molecule of I2 to produce C3H6I2 plus I dot. And we can see that the iodine, if I just circle that in green, the iodine, look, has been regenerated. So it was used up here and then it's given back to us at the end. And we have made our product there, the 1,2-diiodopropane. Termination. I just said termination involves the combination of the radicals from the very first step. Let's look at the possible combinations. So what are the radicals in the first step? Well, if I just put a tick next to them, it's this one and this one. So what combinations can we have? Well, we can have I dot plus I dot goes to I2. We could have C3H6 I dot plus I dot would produce C3H6 I2. And then the final one, so if I just put numbers in these, so the final one, and then the third one, if I just write it here, I don't want to keep everything on the same screen with this one. So the third one, what do we got left? Well, we could have C3H6 I dot plus another C3H6 I dot. And what does that leave us with? C6H12I2. So we've made diiodohexane. If you have any questions about this, please do comment down below and I will get back to you and help you. If you found any value, please like and subscribe, and check out all the other videos I've produced on organic mechanisms as well as the other parts of the chemistry syllabus you see in high school. Thanks for watching, and I will see you in the next one.